about gas stoichiometry. Yay! So we've done solids, now we'll do gases. So think back to our gas laws where we were able to solve for how many moles of gas we had, okay? So we're going to have to use gas laws to find moles of gas, okay? So it's kind of will be fun because you'll be reviewing all your gas law stuff. Excellent. So keep in mind the 5 steps for Stoich. You don't have to write these down again, but we write our balanced equation, we identify wanted and given, calculate your given moles, compare the moles of given to calculate moles of wanted, and then convert the moles into whatever units specified in the question. Okay? In these kind of particular questions about gases, it might be things like volume, you know? Because that's kind of usually when we measure an amount of gas. So, again, the diagram I showed you yesterday, so we've done figuring out, like if we're given a mass, we convert it to moles, do our mole ratio, and convert back to mass. So now we're going to do, we have a volume of gas, we have to put it into moles, do a mole ratio, find moles, and put it back into volume. Okay? And then you will do this. Stoichiometric calculations. I'm awesome, right? Not this. Stoichiometry, frustrating chemistry students since 1792 when we were able to use mole coefficients to convert. You won't feel like this, though. You'll feel like this. Great. Glad you all agree with me. I was so excited to show you those, but apparently you don't care. So next thing, let's write in a little definition to help us remember. Molar volume. This was the volume occupied by 1 mole of gas at a specified temperature and pressure. In units of liters per mole. Now the two that I gave you, and you spent some time and you memorized these actually, remember a couple months ago? STP was 22.4 liters per mole. SATP is 24.8 liters per mole. And our formula that we use for that, so you can kind of put that to the side there, is V is equal to Vm times N. Where big V is volume in liters. V subscript M is molar volume. And N is mole. So we can use these formulas to apply to gas stoichiometry. You might be given situations where you'll be given like temperature, pressure, and volume, and you can use your, so the other formula that you could also use is PV equals nRT, okay, where P is pressure, V is volume, T is in Kelvin. Remember, so if you're given your degrees Celsius, how do you convert to Kelvin? You add how much? 273. There we go. Good. See, you do remember to get to our Kelvin. Our R was a constant. Do you remember what that one is? You have your gas sheet out? Good. Yeah, what is it? 8.3. Yeah, 8.314. Is it 4.1 or 1.4? 1.4, right? Yeah. And those are the R value, I'm pretty sure, is in your data booklets too, like in your constant. So just remember, you might be given information about that and solve for n. So to rearrange, you go PV over RT is equal to n. Okay? So yeah, I see, Rachel, you brought out your gas law stuff. That's probably a good idea. Is if you can, if you've got an organized binder, you can find your gas law sheet so that you have all your gas formulas out and for you to do. All right, so let's do an example.